Hello everyone, welcome to the topic theoretical distribution under the subtopic binomial distribution, and it is presented by Shantala Kulkarni, Department of Statistics, Gokte PU College of Commerce and Science. In the previous class we have solved examples on binomial. In today's class exclusively we will solve examples on recurrence relation, how the recurrence relation formula is applied to an example, and then how do we actually apply a binomial distribution for one just observed frequency distribution. Now what is the example here? The following data relates to the number of defective items in a sample of 5 for 500 samples taken during a week. Number of defective items, number of samples, fit a binomial distribution to the data, obtain the theoretical frequencies. When the word comes fit a binomial distribution means this data is known as observed frequency. It is a simple observed frequency. This is the value of x and this is the value of f. To this simple observed frequency distribution we have to fit a binomial distribution, means we have to follow the rules of binomial. We have to write the probability mass function, we have to apply the recurrence relation. All these things we have to find for this simple data and check whether how we have to derive the theoretical frequencies. Now the solution, what does it say? X is the number of defective items in a sample of 5. Then X follows binomial distribution with parameter n 5 and P as it is. Here P is estimated from the given data. We have to find the value of P from this particular data. So what is the first step? The first and foremost step is to find arithmetic mean. Simple arithmetic mean you have to find. That is, so x bar is equal to summation fx divided by capital N. This is your x, this is your f. You have to multiply f into x. This is 0. 1 into 80, 180. 2 into 120, 240. 3 into 20, 60. 4 into 10, 40. 5 into 2, 10. If you remember for the PUC one, how do you find the arithmetic mean? The same formula we are using for the direct method, and then we are totaling this. This is summation fx. This is summation fx 530 and total n is 500. So x bar is equal to 1.06. The first step is to find the arithmetic mean. Next, after finding the arithmetic mean, we are going to write the binomial parameters. What is the binomial parameter? X bar, arithmetic mean is represented by NP. So we will substitute. Now here x bar is equal to NP, so P will be equal to x bar divided by N. We found the value of x bar, that is here 1.06, so we will substitute 1.06. This small n is the maximum value x is taking. See in the example, x is starting from 0, 1, 2, 3, 4 and 5. So here this is n, the maximum value n will take is 5. So we have substituted the value here, small n 5, capital N is equal to 500. That is the total frequency. So after you substitute, you get 1.06 divided by 5 is 0.212. You got the value of P. So you have to find the value of Q, that is 1 minus Q. Substitute and we have done it here and you get the value of Q. So I am telling the first step is to find the arithmetic mean, and that we will be equating to the binomial parameters. With the help of that we find P, we find Q. This is the first thing you have to do. Next is to write the probability mass function. You have to write the probability mass function, write the general term of the probability mass function of the binomial distribution. Then you are going to substitute what is the value of n, it is 5, value of P 0.212, value of Q 0.788 to the power of 5 minus x, where x takes the value minimum it will start with 0, maximum it will go with 5. Before you apply the recurrence relation, the first and foremost thing is you are going to find the probability term where x is equal to 0. Means wherever x is there, you are going to put it as 0. So this becomes 5C0, 0.212 to the power of 0, 0.788 to the power of 5 minus 0, So when you simplify, I repeat once more, anything to the power of 0 will always be equal to 1. So this term, whole term becomes 1. Then when you multiply 0.788 5 times, 0.788 into 0.788 into 0.788, you want to multiply 5 times, you get this answer, 0.3038. So first is to find the probability term. Then you apply this formula. This is the first term to find the theoretical distribution. The formula is T0 is equal to capital N into probability of 0, this answer. So here capital N is equal to 500 and this value is here. So when you multiply, you get 151.9, that is, which is approximately equal to 152. If this decimal value here is more than 5, you will approximate to the next highest value. And if this is less than 5, you will reduce it, or if you will make it as 150. Remember this approximation. So the first term is to find P of 0 and then you find this theoretical frequency. After you find this, then you can apply the recurrence relation. If you do not want to apply the recurrence relation, you can go with the same formula. T1 is equal to N into P1, then T2 is equal to N into P2. We have done that. We have solved that example in the previous example. But when such examples are there, applying recurrence relation becomes very, very easy. So I hope you all understood up to here. Now we will see how to apply the recurrence relation and solve the examples. Remaining frequencies are obtained by using the recurrence relation. Now see, the recurrence relation formula is Tx n minus x plus 1 divided by x into p upon q into tx minus 1. We will see this. What is the first term here? First term, see, you have already found T0. We have found that 151.9 you have found it. That is equal to 152. You have found it. Now we will find the next term. The first term is always T0. Second term is T1. Now this here in T1, what is the value of N5? X. This is X. It is 1. This 1 is 1 here only. And this X is 1 here. P upon Q. Substitute the value of P. Substitute the value of Q. Here, please pay attention. T, what is the value of X here? 1. 1 minus 1 is equal to T0. You have already found the value of T0, that is 151.9. So you only have to substitute it. So you have substituted all these values. 5 minus 1 is okay. Minus 1 plus 1 gets cancelled. 5 into all, when you simplify, you get the answer 204.3055, that which is approximately. See, the decimal point here is less than 5. So you are making it less. So it will be 204. This is T1. Similarly, we will find T2. T2, what the value of x will become? 2. This n will remain same, 5. X will become 2. This 1 will remain same. This will become 2. PQ will remain same. Here, T x minus 1, 2 minus 1, it will be 1 here. So you have to write this a T1 term. So 2 into this and this 2 value here, T1 value. When you simplify, you get the answer, and you are approximating. The decimal point here is more than 0.5, so it becomes 110. You are approximating. Similarly, T3. T3 we are going to find the value of x is 3. Here is 3. P and Q are here same. Then here T1 becomes T2. You are substituting the value of this point. This value you are substituting here. When you simplify, you get 29.57, which is approximately equal to 30. Similarly, when x is equal to 4, n remains as it is, 4, 4. This is the value of P and Q. T3. T3 value is here, 29.57. And you are going to take T3 value, this decimal value, not the approximated value, not the approximated value. You are going to take this decimal value, you are going to write here. Here also the decimal value is written here. So you get the answer as 3.98, and which is we are approximating it to 4. The last one, T5, that is 5 minus 5 plus 1 divided by 5, the value of P and Q, T4. You simplify, substitute all the values, you get it as 0.2141, and this decimal is less than 0.5, so you equate or approximate it to 0. So this is how you find the recurrence frequencies, or expected frequencies by using the recurrence relation and get the expected frequencies. Now the last step is to write everything in a table form. This is your x value. This is your observed frequency which is there in the question. Then after applying binomial distribution, you have to obtain this theoretical frequency. So see this. You have to approximate in such a way that this total has to be 500. This total has to be 500, that is matching with this total. So this is how you fit a binomial distribution to a observed frequency by applying the probability mass function of the binomial distribution. See children, as the portion is cut, they have reduced it, I feel that this question can be a 10-mark question. You can practice it also, and if you practice, things will always be easy. It is a very well known fact. As much as you practice, even the toughest thing is going to be easy. We will solve one more example. What does the next example say? 7 coins are tossed 128 times and the following distribution is obtained. Number of heads, this is your x and this is your f. The minimum value is 0, maximum here it is 7. So here small n is equal to 7 and your capital N is equal to 128. Yes. Now the question says fit a binomial distribution when the nature of the coin is not known, obtain the theoretical frequencies. This is the main thing. You have to obtain the theoretical frequencies by applying the rules of binomial distribution. So what is the solution here? X follows we say x is the number of heads obtained when 7 coins are tossed. Then x follows binomial distribution with the parameter n 7 and p as it is. P we have to find. So the again first step is to find x bar, that is summation fx divided by capital N. So this is your x, f into x, the first term is 0, then this one is 7, 2 into 20, 40, 3 into 26, 78, 4 into 30, 120, 5 into 21, 105, 6 into 14, 84, 7 into 3, 21. You are going to do, this is your summation fx, this is 455. You have done this in PUC on finding simple arithmetic mean. So x bar is equal to 455, the total is 158 capital N. When you divide it, you get it as 3.5547. So the first step is to find this arithmetic mean. After you find the arithmetic mean, you are going to apply the binomial parameter. Yes. You apply the binomial parameter to for a binomial distribution, the mean x bar is equal to NP. So P is equal to, P remains here, x is here only, n comes down, n comes here. It is how it is written. So what is x bar? 3.5547, n is 7. So this is 0.51. You can approximate. Then you find the value of q. You get it, 0.51 is equal to 0.49. So once you get the value of p and q, you write the probability mass function. You have written the probability mass function, then substitute the value of chotu n, then you substitute the value of chotu p, you substitute the value of chotu q, and then you write this probability mass function. Again I am telling, the first step is to find the probability x is equal to 0. First thing is you are going to find this. Then after you find this, you find the first theoretical frequency, and then after this you will be applying the recurrence relation. So 7C0, the binomial coefficient, you can find it from the statistical table. Anything to the power of 0 is 1. This you are going to multiply 7 times, and when you multiply 0.49, 7 times, so this is the answer you are getting. This is P0. Okay, and our first step is to find P0, and then you will be finding T0. T0 is the first term, that is the theoretical frequency, that is capital N into P0. So after doing this, you will be applying the recurrence relation. Your n is to 128, P0 you have found this value, approximated, decimal point is more than 0.5, so this will become 1. We will see the next terms by using the recurrence relation. This is the recurrence relation here. Yes, the recurrence relation, Tx is equal to n minus x plus 1 divided by x into p upon q, Tx minus 1. See, p upon q, this value remains constant, it will not change. The only change will be happening in this formula, x will keep on changing and this term will change, and this term also, the first term when you find, that is what you will be writing here, that's all. So the first term here, x is equal to 1, tx 1, 1, I put here 1, 1, p upon q, p value is 0.51, q value is 0.49 into t0. This is 1 minus 1 is 0, so the t term you have already, t0 value is already found out previously, so that you are going to substitute here and you get this value. Clear? Next one, t2 also is found in the same fashion. You substitute the value of t2, substitute systematically, do it step by step, and you get the answer 19.7178, which we approximated to 20. Similarly for t3, means the value of x is 3. Here see, it is all same. These values keeps on changing and these values are nothing but here. Yes, this is how you write. It's very simple. The only thing is just pay attention. Things are really simple, and I always tell, if you all remember in the classes, the more attentive you are, the things are going to be very easy and simple. Just pay attention. You give your 100% and things are going to be very easy and simple. So similarly we will find T5, T6 and T7, and all these values are found, and after you find these values you have to substitute or put them in the table, and when you put it in the table, this is your original data, and then when you apply the binomial distribution you get the theoretical frequency. It is also known as expected frequencies. You have to, why are we doing this approximation, decimal point and all that? Because we want the total to both to be 128. You remember in the first class we had taken Pascal's triangle. That is the first thing to see, that all the total frequency are approximating to always that same thing, whether it's horizontal or vertically. So the same thing is, you apply any distribution, at the end you have to approximate in such a way that the total frequency are same and they are matching. So these are the two examples on theoretical frequencies on binomial distribution, and please practice. We will solve the next example, which is a 2-mark example. Means how the data is represented and how do you approach it. Such kind of examples have come in the examination. We will see what it is. In a binomial distribution with parameters n is equal to, with parameters n is equal to 3 and p, the value of p is not known, it is just written there. The second and the third frequency terms are 32 and 30 respectively. Find p. See what data is given to us, only the parameter, actually the binomial parameters are n and p. Only they have given the value of n, we have to find the value of p. With what data? Second and third frequency terms are 32 and 30 respectively. Find p. Now see, whenever we say third frequency, first frequency, your number immediately jumps to the usual, number. Second means you are going to write it as T2. It is represented. But here in this particular example, T0 is the first term. T0 is the, remember in the theoretical, especially the discrete, this is the first term. T1 is equal to the second term. So here your T1 is equal to 32. Your third term T2 is equal to 30. And how do we write this? How do we write? Given T1 is equal to 32, and what is the formula of T0? N into P0. Similarly, T1 will be N into probability x takes 1. So that is what we have split up here and written. Capital N is here. This probability mass function we have to write 3C1 p to the power of 1 q to the power of 3 minus 1. We are going to see, we have written here in the form, in this form only. Okay. And then what we have done, p to the power of 1 and 3 minus 1, it becomes 2 here. See, we have simplified. 3 minus 1 is equal to q to the power of 2. This is, we write it here. This is the first thing. Then similarly we will write T2 also. T2 is what? It's actually the third term. So 3c2 p to the power of 2 q to the power of 3 minus 2 is equal to 30. This is given. It is this is given in the question. We are only expanding this and writing. That is, finally it becomes 3c2. You have to find this value, the binomial coefficient. Here also this value is found. It is 3. 3c2 again it is 3. Then p to the power of 2. Then 3 minus 2. This is 3 minus 2. This is 1. So it's not written. So this becomes 30. Now we have to find the value of p. You put the equation on 1 or 2 or 2 on 1, any one step will increase. So when you put this equation 1 upon 2, that is you're dividing or putting that in the form of a ratio. So this is equation 1, the value is here. This is equation 2, the value is written here, and the total value 32 divided by 30. This total also we have, that value also we have to take. What all gets cancelled? Capital N gets cancelled, 3 gets cancelled. P is here, 2 P's, 1 P remains, Q square, 1 Q remains, correct? So in the denominator Q is remaining, and in the numerator Q is remaining, and in the denominator P is there, that is 32 divided by 30. So what do we do here? The next step is to cross multiply these two. Cross multiply. Okay. Cross multiply. You get 30Q is equal to 32P. Either you want the value of P. So you change this Q in terms of P. 1 minus P. We have written here. 1 minus P into 30. So you multiply this. 30 into 1, 30 into P. So 30 minus 30P is equal to 30P. 32P, sorry. Then this 30P you take it to the right hand side, you bring it here. So this becomes 30 is equal to 32P plus 30P. 30 is equal to 62P. The same thing is here. So therefore P is equal to 30 divided by 62, which is your answer, which is written and simplified. This can be a question of 2 marks. It is simple. Pay attention, go through step by step, practice it, you will understand. So with this, in today's class, we have solved examples on recurrence, exclusive recurrence relation by using the recurrence relation formula for binomial distribution, and then finding the theoretical frequencies. So remember children, do it step by step and practice. Things are going to be very easy. Every class I do mention, you people have doubts, please come to the college and clarify. But the thing is practice. So for today it is done. Thank you children.